Welcome to the 3D Design Workshop. This is lesson number 4. So here's our agenda, or what we're going to talk about for today. First, we're going to talk about the 3D printing process. Then like different CAD softwares, you know, like Tinkercad and like other CAD softwares. What is a STL? What?
Don't you use Fusion 360?
Yeah, I'll talk about those later. What is an STL file made of? What a slicer does? Support material? Then everyone's going to share their design. And of course, we'll also have a 5-minute break, as in last class. But yeah. Okay. So here's the 3D printing process. So you first sketch a model, or sketch the model that you want to make on paper, and make sure you know what you want to make. And then So you do that just to make sure that you're not like wasting time just like playing around with that stuff. I mean, although it is pretty fun to play around on Tinkercad and other things. And then you would design the model on a CAD software. CAD stands for Computer Aided Design. So like Tinkercad would be a CAD software. Fusion 360, which I'll show you later, is also a CAD software. There's Blender 3D, which is also a different type of CAD software. Like, I know this is like new, so I'm gonna talk about it later. And then form it into a STL file, which I'll talk about later too. Then you bring it into a slicer and change it to G-code. Then you start the print. So here is some stuff. So you might be able to, like, here is Tinkercad. Here's Tinkercad. You can see that's like a crown right there. Something you can make in Tinkercad. It's also one of the more basic things that you can make in Tinkercad. You can make a bunch of other stuff too. And then Fusion 360, which you can make like a robotic arm or a prosthetic arm in.
Does it work? Like,
yeah, it does.
How can you 3D print an arm that can move?
So, well, actually what you would do, you print it into separate parts and then you can snap them together later. So It's not print in place. It's like, it requires an assembly. And then Blender 3D, this thing over here, it's actually not like, oh, I want to put basic shapes together to form this thing. Actually, what you're doing is, you're taking a sphere and you're forming it into like different shapes. Like you would take a sphere, stretch it and pull it and everything into this Batman. So this is, like, I'll show you Fusion 360 later. Blender isn't really related to like what we're learning in this type of class. It's like this Blender is sculpting. So yeah. Okay. That works. Okay. So what is an STL file made out of? The simple answer is a bunch of triangles. If you want the long answer, it's still a bunch of triangles. So let me show you in Fusion 360. I'm actually going to stop the share and then share screen again on right there. Okay. So cancel, okay? So here's a sphere. It's just a normal sphere. Nothing special about it. It's just a sphere. Now, if you want to 3D print this, you can't just drag and drop this into your 3D printer. You have to go through a process of steps in order to do it. And to translate this shape into like, I guess, a portable set of data and then put it into another device, what you have to do, you have to form it into triangles. Well, triangles isn't the only option, but triangles are like the simplest shape there. So actually, each of the triangle's points, like its vertices, say there's a triangle right here, okay? That point would be recorded, well, you saw in the first lesson, the XYZ dimension, like the X might be, the X value might be like 3, the Y value might be 5, and then the Z value might be like 20, and then that would get that point. And then what it does, it remembers each one of these points, and then depending on how many triangles you have, it would save those points and then put it into a slicer. So here, I'm gonna show you. I'm gonna save as an STL file. Now my computer's going and it's generated a bunch of triangles. If you zoom out, you just think it's some black sphere, right? If you zoom in, you can actually see all the triangles here.
Ooh.
Yeah. And if you want, well, actually, look down here. Do you see, wait, look down here. Do you see that number right there? That's the number of triangles. There's 28,560 triangles in this whole thing.
What?
Yeah. And then depending on this, I'm just gonna exaggerate this a little bit for you, but if you change it to, well, low, it's not gonna be like these triangles, because this, oh God, my computer just shut down, okay. So you can see here, if it's a low refinement right here, what it's actually going to do, it's actually going to have less triangles. So when you 3D print it out, it's not going to be as smooth. It's not going to be as smooth of a shape. It's going to be like, yeah, it's not going to be that smooth. And then if you change it to custom and you really want to exaggerate that, okay, my computer's going to slow down a bit here. Change it to custom, drag it all the way there, drag this all the way there. You can see like there's less triangles. And then, well, you can't really see it here, but if I put this into my slicer, you'd see it's just chunks of triangles that you can actually see. So let's say I'm gonna save this as a sphere right now. So a very low quality sphere, okay. I'm just gonna name it sphere. I'm gonna put it into downloads, save. And then now I can open up, oh, well, that's an STL file. And then let me go, oh no. Okay, so that's what an STL file is. Can you guys all see that? Did you guys all see that? Okay, cool. So, now I'm gonna talk about slicers. So why is it called a slicer? Anyone have any guesses? Alan?
It slices things.
That's a good guess. Anyone else have a guess why it's called a slicer? Oh, Roger? Do you want to say something?
No.
Okay. Alex, do you want? Oh, never mind. So anyone have a guess why is it called a slicer? Anyone? Roger?
Because when you press the button, it goes into more triangles.
That's very good. That's a very good thought. Anyone else? Oh yeah, Peter. Peter, if you want, you can just unmute yourself and speak.
I think it's called a slicer. Maybe, I don't know. Maybe like when you put the parts together. No. Maybe I don't know.
It's fine.
Triangles.
Anyone want to take a guess? Okay. So actually, it's called a slicer because
It's sharp.
so what it actually does is slices your shape into many two-dimensional objects. So because the 3D printer prints layer by layer, so it slices it into 2D, very small 2D slices, and that's why it's called a slicer.
So it's like More than 1,000,000 triangles in one sphere.
Well, actually,
Inside.
so actually what it does, it's not about like triangles and stuff. Like the triangles are to make sure to record every single point. So once it gets into the slicer, they can form the shape. And well, it's called a slicer because it takes your slices, because it slices up your file into layers. It's formed. So I'm gonna take it to Kira. Oh no. Okay, I guess I have to reopen it.
Goofed.
Yeah. So right now, Kira, which is my slicer right now, is loading.
Altimeter.
What? Sorry, what did you say?
It says Altimeter Kira. Why do you do
Ultimaker Kira. Yep, 4.5. Oh, that's the slicer I have installed. And
I'm gonna
okay, there we go. So, Alan, could you be quiet, please? I'm gonna actually open a file, and you can see on my downloads here, if you search.
Eric,
Yeah.
since I can't share it, the thing if like you have to share, so I'm choosing to do it on my iPad instead of the computer.
Okay. Oh yeah. So I don't just share screen for now, but I'll enable it later. So I'm actually gonna open my sphere right here. Oh,
Roger left the meeting.
okay. And then I just I think Roger's connecting.
Okay.
Oh yeah. Okay. So sphere.spo, I'm gonna open that. Here's a sphere. That was the sphere. And you can actually see layers because of the low quality of the STL. Do you see that? So here. Okay, here, I'm gonna mute you right now. You have a lot of background noise, okay?
Mhm.
Okay, so right. So you can see the sphere right here. And can you guys see like the little chunks right here of the sphere?
Yeah.
Yeah,
Mhm.
that's because of the low STL file quality.
What's the red thing on the bottom?
That's gonna need support material, which I'll talk about later. So the sphere is right here, and you can change the slicer settings. I'm not gonna change them now. I'm just gonna slice it. Well, it's processing right now because, yeah. Okay. So I put my thing at a super low print speed. If you're gonna print a sphere, it's probably gonna take like 2 hours, not 15 hours. And here I'm gonna load a preview. And actually, let me go to layer view. Wait. Go to material color. Okay, that's better. So now you guys can actually see how this sphere will turn out. And if I drag this part down, you can see that my sphere is a sphere. But yeah.
Layer by
What?
layer by layer.
Yeah, it's going layer by layer. And if I can just press the play button, and it'll actually start playing what it's gonna look like.
Wait, actually?
Yeah. If I press
Is the 3D printer printing it now?
No, it's not gonna print it. It's just gonna tell you like how it's gonna look when it prints. Like
Oh.
there's a nozzle of the, where the little thing that's laying down filament is.
Can I see it?
It's that yellow thing right there. Here, I'll annotate.
Oh.
Yeah, it's that. Oh God. Okay. It's this thing. It's that. Okay. Never mind. So right now it's playing. Like it's gonna show us how it's going to draw the stuff, and that's basically what a slicer does. It just takes everything up, puts it into, well, in my case, these 506 layers, and then it's just gonna transform it into machine code, well, G code. I think you might. Yeah. So, like this slicer doesn't allow you to change the G code, but there's more than one slicer, and I have another slicer installed called Prusa Slicer and Creality Slicer. And basically, the G code is basically.
Eric, I can't really focus because it keeps on saying Lei Chen will like FaceTime. Huh?
Okay. Okay, so that's pretty much what a slicer does. Now, support material. Where support material will be needed. First, I'm going to talk about what support. Oh. So support material is basically a side structure that your computer will print out because parts. So one example of support material, like where support material would be needed, overhangs over 45 degrees. And if it's over 45 degrees, that, like, if it's 90 degrees, this will happen. This will happen. See, that's over 90 degrees. If you're trying to print like a T, for example, and you don't have support material and you want to print it this way, there will be like stringing and everything. Not the most beautiful sight.
You should print the T the other way, and then when you're finished, you just print it right, and then you just flip it over.
Yeah, that's actually a very good observation. Basically, it's like good to think about what orientation you could put your print in to save more material. So another thing which needs support material is floating parts. So floating parts aren't the greatest thing because you could just put it down onto the print bed and then it wouldn't need material because of gravity, if you just print in the air, nothing will like stick down and it's just gonna be a stringy mess. And
yep.
So if you have any floating parts, make sure you click on it on Tinkercad and hit the key D to drop it flat onto the work plane. So that's pretty much all the talking I'm going to do today. Now I'm going to allow you guys to share screen and talk about your jet designs.
How do I get closer?
So, Roger, would you like to tell us about your design?
So I got inspired to make a rocket because I wanted to make a toy, and all my toy planes are like, I think I lost them. I mean, I lost my toy planes. I thought it was gonna be helpful to cheer my spirits up by making a rocket. And I never made a rocket before.
Would you like to tell us like what shapes you used for your rocket?
I used cylinders for the body. I also used the yellow cones for the flame. And what was that?
Like text box?
Yeah, I also used the text box and it says room.
And then
And the top thing, I used an olive. And I changed it to the red color, like I changed the cone to the yellow color. So now looks like hot, like the rocket looks very hot.
yeah, it looks like
That's
I like it. Anyone else have a design that they want to share with us? If not, Roger.
How do you screen share that?
just press share screen.
Yeah.
Or share content.
Yeah, but then
I
there's like
just
a
share-
bunch of things. Oh yeah,
Yeah.
since you need iOS or something.
Oh, okay. Alex, tell us about your design.
Oh well, I searched up pictures of jets on Google and I kind of got inspired by some ideas. So I used the ideas and just built this jet.
Would you like to tell us like what challenges or like what challenges you faced or like what shapes you used?
I used like cylinders and I used like the wing things and I used a cylinder for the tip and I used a half circle on the top.
Very nice. Anything else you want to talk about?
Oh yeah, I also got worried about like making like because like under the wings it wasn't 45 degrees, so I thought I'd have to make ginormous boxes.
Okay, cool. Anyone else want to talk about their design? Alex, do you want to share a screen of your design or anything? Like you can share any design, like your past.
It says you need iOS 12 or something.
Uh,
But I have a code.
Yeah, so-
So for the fire, I didn't know what to make, and then Alan said you can go to the gallery. So then I went, but then Alan said you shouldn't exactly like copy and paste from the gallery. So then I took one of the small curvy shapes and then I copy them and then put it on the back.
Anyone else want to talk about their design and like how they made it, where their inspiration came from, and like any challenges they faced? I know like sometimes a challenge for me is in Tinkercad there are a bunch of shapes, and then I can't like get all of them together in the right spot because like when I click one, I accidentally click the other one, and it gets kind of really annoying. Anyone want to talk about their challenges? Or maybe their mistakes or their past designs? Sweet. I know you guys all have to design. Did anyone actually sketch out their design before like they made it? Like sketch out their design on paper, and like before they made it. Paper didn't like sketch that out. Okay, I guess I'll just show you guys how to share the link with me. Okay, new tab, Tinkercad. Now, I'm already signed in. Let's say I want to share my jet with someone.
Mhm.
Now I'm gonna press tinker this.
Send to.
Here's my jet design from last week. And I will show you how you import export STLs. If you buy a 3D printer later or you have one at home, this might be of use. So you can actually import stuff. Like I could choose a file. I could go to, let's say, load, and then PowerPoint. Now it's going to import it. Okay. This PowerPoint is like an online website. It's kind of like slow if your internet's not perfect. And okay. Well, while we're waiting for that, I'm gonna show you guys how to export for. Oh, okay. Here it goes. I think it's only.
Oh, that's a lot.
Yeah, so I'm going to rotate it.
What is that?
Flower pot thing, kind of. So here's my. I'm gonna rotate it 90 degrees.
There's a
Oh my
jet
God.
under it.
It's.
But why are you putting a jet under a flower pot?
I'm not. I'm just showing you guys.
Why you shouldn't put a jet under a flower pot?
Yeah, Peter.
Why
It's a very good idea. You should try it.
Really, put a jet under a flower pot?
It's a very good idea.
And you make it a real jet so it goes on fire and your plants burn.
Okay.
I'll just burn the flower pot.
So let me delete that.
It's gonna be made of plastic, so it's a burning jet. Yay, now the jet's not gonna burn the flower pot. Now the flower pot's way smaller than the jet.
Yeah. Okay.
Are
So
they playing fencing?
I mean,
The
still.
jet can stab the flower pot in a minute.
I hope that doesn't happen because. Okay. So my flower pot. Okay, you can import by that one. Import. Choose a file and then import it from the computer. Or you have, and then right now, what you want to do for if you want to 3D print it, here's when you don't have a 3D printer. 3D print. Please unmute yourself because there's kind of a background sound and okay, good.
Peter.
Yeah. Sorry, Peter. Just I think there's some background sound in your background. So right here, okay, you can see there's different 3D printing companies here.
Mm-hmm.
You can send that there if you don't have a 3D printer. If you want to download it to your own 3D printer, you would download .stl because, well, that's what, like, it's easiest. And, like, that's going to download your model, and then it's going to open it automatically. Hopefully my Ultimaker Cure doesn't shut down again. If you have your flower pot ready, you could just that's pretty much it. If you want, say you have a box and a cylinder and a jet, and you don't want to print the whole thing. You don't want to print a box and a jet. You only want to print a jet. Select the jet. Select the jet, okay, and then right now you can press export STL, and then you could choose everything in the design, which includes the key, or you can click only the two selected shapes, and then you click STL blah 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 again. So here it is in Cura. There's my little jet. Yeah, you can see the jet right there. And pretty much all there is. You can press slice. And then, well, right now I'm going to show you how you do stuff if you have a 3D printer. And here, press save to file. Or if you have like USB adapter, you can just plug that into your computer and it'll say save to removable drive. And you can press save to removable drive. And then, well, I'm first going to see how it looks like. This thing is going to need some support material because the overhangs are the wings can't be printed like that, so they have to require some supports. Also, on the side of that cone for the nose, and like if you go to the preview, the tip is just completely obliterated. You can barely see it. Okay. And safety or safety removable drive, and then you can just actually might be able to show you what some G looks like. I'm actually gonna need to stop share and then share screen again. Like if any of you if any of you is moving right now or something, these okay. If I open this, open this. And this is what some G code looks like.
Ooh, okay.
What some standard G code looks like.
Looks like a lot of numbers.
Yeah, it is a lot. Yeah, Roger, that's right. It is a lot of numbers. See, like this part stands for the extruder gear, which is going to start pushing. This is the X dimension, Y dimension. Every single once in a while, you'll find a Z dimension.
Z? Let me check.
Here's a Z dimension right there. And then basically it's just telling us like how to move, like where to move and stuff. You can see it's a bunch of...
I still can't see any Z's. I saw one.
Oh yeah, so because when a 3D printer prints, it prints layer by layer. So it doesn't need to move in the Z axis that much. But if you really look for it, or in my case, Control F, Z, find next. And there's a Z right there.
Wait, what?
There's a Z up there.
I just can't see it.
You see the Z right here? That Z, it's highlighted in blue.
Oh, yeah.
Yeah, so it basically dimensions and stuff, but that's okay. That's pretty much it for this lesson. If you guys want to talk about your designs or anything else, you guys can talk about it now. But